Hey, I'm Sally from SIG Observability. I'm going to show llm-d distributed tracing. It's a feature coming soon. Also, the NIXL metrics in vLLM that you maybe haven't used yet. This example showcases heterogeneous parallelism, where you replicate prefill for throughput and wider decode for KV cache memory. We'll start talking about the metrics, but then you're going to see how distributed tracing can also help. I tried to get a script to exercise the full range of the prefill decode scenarios. So what is the observability gap with PD mode? The request comes in, the gateway routes to the prefill instance. The NIXL transfers the KV cache from prefill to decode. The decode instance then generates tokens using that transferred KV cache. The problem is that each vLLM instance only reports its local time to first token. So you can use the prefill and the decode time to first token to get the true end-to-end average. And then also the bottom part of the dashboard focuses on the KV cache transfer with these added NIXL metrics that are available in vLLM. So if this KV cache transfer time was unacceptable, you might consider RDMA or some other networking optimization. It also shows the average size of the KV cache transfer, and that is dependent on your prompts, the prompt length. My main goal of this demo is to highlight the power of distributed tracing. There's a proposal in llm-d, the Gateway API inference extension tracing instrumentation has just merged, and there are a few open PRs left in llm-d to get all of this in the next release. So this metrics dashboard shows the aggregate performance, like the P50, P95 values. It doesn't show why a specific request was slow. It doesn't show what was the exact path that a request took through the system, what decisions were made for individual requests. What's the relationship between operations? What's the relationship between these components? Also, this request level context, like cache hits and routing decisions and user attributes. Here's a single trace that shows the precise prefix cache aware. So the request goes through the gateway and then goes through the EPP pod scoring. The K shows the decisions being made throughout the system for a single trace. And then finally, the vLLM request. The domain experts of each repo can then go in and fine grain the information that they want to get from these fans. So with a PD disag trace, you get a complete story of a single request that flows through prefill to decode, starting with the Gateway API request that was just merged Friday, and then flowing through showing the decisions and how long it took to flow from prefill to decode. And if you look closely at a vLLM span, you can see the token usage for cost attribution for this specific user or request. The key differences with metrics and traces. Metrics shows what's our aggregate latency, what's the average latency across all requests, where these traces show what in individual requests, what path did it take, what decisions were made. A system like llm-d, you really need both metrics and distributed tracing to get the full understanding. To summarize, the PD dashboard provides the complete observability using vLLM's native metrics, and the distributed tracing gives you the request level picture of an llm-d system.